guys, welcome back to TechDose, and in this video we will see different ways to add parenthesis problem, which is from Leetcode number 241, and we will see the simple approach as well as the most optimal solution for this. We will start with recursion and solve it optimally by dynamic programming as well, and we will use the divide and conquer method to solve this entire problem. So let's look at the problem statement. In this problem, given a string expression of numbers and operators, we need to return all possible results from computing all the different possible ways to group the numbers and operators. You may return the answer in any order. The test cases are generated such that the output values fit in 32-bit integer and the number of different results does not exceed 10 to the power of 4. If you look at the constraint of the problem, then it says that the expression items do not exceed 20 items, that means from 1 to 20, okay, and they have their operators as plus, minus and multiply, and all the integer values are in the range of 0 to 99, that means either they are 1 digit or 2 digit number. Let's now look at an example for better understanding. Now let's say that your given expression is 2 minus 1 plus 3. Now imagine in how many ways can you bracketize this and what all answers can you get. So one way to bracketize is first you calculate 2 minus 1 and then add 3 to this. Okay, so you can put a bracket like this, and so your answer will be 4. Another way to solve this problem would be to first calculate 1 plus 3 and then put the larger bracket and solve it with 2. So in this case it will be 2 minus 4, which is minus 2. So these are the two possible results. Even though you get the same result 2 times, you have to include it 2 times into the answer array, and you can include it in any order possible. So in this case the answer can be minus 2 comma 4 or 4 comma minus 2. I hope you understood the problem statement. Let's first understand about the expression tree before moving to the solution. What is an expression tree? Given any mathematical expression, we can represent it in the form of a tree diagram in such a way that all the internal nodes will be operators and all the leaves will be operands. Now whenever we want to build an expression tree, we need to do binary partition moving top down, just as we do in the merge sort solution. And when we move bottom up, then we need to calculate the expression. Now if you look at this expression, then which operator needs to be processed at the end? You know that this multiply will be processed at the end, so it will be on top. Now a plus b will be on the left side, c minus d will be on the right side. Now plus will be at the second level along with minus. Now whenever we want to do calculation, we move bottom up and we calculate so that lower level operators will be calculated first. So I think now you can relate how this was built. I will build some expression trees and show you how it is done. Now in order to represent an expression tree, let's say that I take an example of 2 plus 1 minus 3. What we need to do is we need to put the operators in the internal node. So I can break it down in any way possible. Let's say I want to calculate plus at the end. So what I do is I will divide that plus into 2 parts, the entire representation into 2 parts, in such a way that the left hand side will have 2 and the right hand side will have 1 minus 3. Again in this 1 minus 3, I can recursively break it down by saying that minus will be made as a node, and then the left side will contain 1 and the right side will contain 3. So using simple recursion and iteration, we can build this expression tree. Okay. Now if I have to build the second expression tree, then what I will do is I will take the same expression 2 plus 1 minus 3 and decide not to break at plus, but then I will iterate and break at this minus in such a way that when I divide it into 2 parts, then the left hand side will have 2 plus 1, the right hand side will have 3. And on the left hand side again I will iterate and break it down at plus so that the left hand side have 2 and the right hand side have 1. And this is the equivalent expression tree, which is tree number 2. Okay. Now if you are imagining in how many number of ways we can form the expression tree with n operators and definitely n plus 1 operands, it is equivalent to your Catalan number, that means nth Catalan number, 2n factorial by n plus 1 factorial into n factorial. I already have a video on Catalan number. You can click on the I button to go and see how to calculate Catalan number. but this is not the Catalan number problem. I just related that if you are given any kind of counting problem, then you can go and solve it by Catalan number, right? Now let's see a dry run to see how to build an expression tree. Let's consider an example 2 minus 1 plus 3. We will iterate from left to right, and whenever we see an operand we will just skip it. So I see 2, I will skip it. Whenever I see an operator, then I have two choices. Either I divide at this point the entire expression into two parts, otherwise I don't divide it. So at every operator I will have two choices. Okay, so at minus I will have two choices, at plus also I will have two choices, whether I divide at this point or I don't divide at this point. Okay, so it is optional. So let's try to follow that approach. When I iterate from left to right and I make a decision that okay, at minus what I'll do is I will divide this expression into two parts. So I will have minus on top and I will have 2 on the left hand side, and I will have 1 plus 3 on the right hand side. When 2 is on the left hand side, it is just a single operand, so no more division is required. On the right hand side, when you have 1 plus 3, in 1 plus 3 you need to iterate from left to right, you just have a single operator. So we will be partitioning at this point, and so the left hand side will have 1, the right hand side will have 3. So if I again build it correctly, then you will have plus here with 1 on the left hand side and 3 on the right hand side. You see that all the leaves are containing the operands and the internal nodes are the operators. If you try to calculate it, it will be calculated bottom up, and this is equivalent to 2 minus 1 plus 3, but then 1 plus 3 will be calculated first because this is at a lower level, and the answer for this will be 2 minus 4, which will be minus 2. So this is what is calculated here. Now if I decide that initially I will not be dividing at this minus and I will just skip it, then using the other option, when I reach to plus, I decided that let's say I will be dividing at this point. So if you do that, then plus will be dividing the entire expression into two parts. On the right hand side you will have 3, on the left hand side you have 2 minus 1. Again 3 is just a single element, so this is the base case. On the left hand side you have 2 minus 1, so you will be iterating and you will be dividing at this minus when you iterate, and the left hand side will have 2, which is a base case because it is just a single element. Right hand side will be 1. So this is how the expression tree will look like. Now this is equivalent to writing 2 minus 1, you calculate 2 minus 1 first and then add 3 to it, because 2 minus 1 is at a lower level, minus is at a lower level than plus. If you calculate it, you will be getting 1 plus 3, and that will be equals to 4. And there are no other ways of dividing this entire expression, so our answer should return minus 2 comma 4 in any order, and this is what we are trying to solve. So if we see any character which is an operator, then we can choose to divide at that given point the entire expression into two parts. Otherwise we do not choose to divide at that point and skip it over and see some future operators, right? So this is just the divide and conquer approach. I would like to announce about our live training programs, data structures and algorithms, which is interview dose, and system design, which is design dose. If you are looking for making a switch from service to product based, or even make a product based to product based top tier switch and aiming for your dream company, this is the best curriculum you can ever join. I'll be your mentor throughout the cohort and I will help you clear all your doubts in the one-on-one sessions. You can know more about this by querying us on the WhatsApp number, or you can also visit our website techdose.co.in. Now let's see another example. What we can do is we can apply the logic of merge sort, how we use divide and conquer in merge sort using low and high. So I will be having an expression and I will be using the low and high pointer just to say what is the range of sub problem that I am seeing. Okay, use the concept of merge sort. Now in this case, again I will be repeating the same process. I will be iterating not randomly but from low to high. I can write an iteration code of simple for loop running from low to high, and whenever I see an operator I can decide to break at this point or not to break at this point. So if I see a minus, I can decide to break at this point, and if I decide to do so, then the left sub problem will have 2, and the entire problem range initially was 0 to 4. Okay, so when I divide at minus, then if 2 is occurring on the left side, its range is only from 0 to 0. and on the right hand side if you see, I will have 1 plus 3, and this entire range is from 2 to 4. Okay, I hope that is clear. Now on the left hand side it is a base case, on the right hand side you have a plus. So if you iterate again, you will have a plus, and you will have to actually divide at this point. So now the plus will come here, and on the left side you will have 1, and on the right side you will have 3. When you divide it on the left side, the range will be divided, and this will be a range from 2 to 2, and the right hand side will be a range from 4 to 4. Okay, so these are all the sub problems which are occurring based on the range of low and high. And another expression tree will be when I decide not to actually break the entire expression at minus but at plus. And if you happen to do that, then at plus we can break, and the entire problem is in the range of 0 to 4. On the left hand side you will have 2 minus 1, on the right hand side you will have 3. This 3 is in the range of 4 to 4. On the left hand side you have 2 minus 1. Now I will be iterating and dividing at minus. So if you happen to do that, then you will have a minus here, and again 2 on the left side and 1 on the right side. This minus will be actually calculating the result of 2 minus 1, which is in the range of 0 to 2. 2 is in the range of 0 to 0. 1 is in the range of 2 to 2. So this will be the ranged sub problems which you can see in this case based on the previous explanation of how we are going to break the expressions, right? So I hope now you have understood how are we going to actually solve it by recursion. The time complexity of this will be order of 2 to the power of n. Here the n value is less than equals to 20. But you know that if n value is less than equals to 20, you will have not more than 10 operators actually. But even if I take n less than equals to 20, it will be 2 to the power of 20, which is equivalent to 10 to the power of 6, and very less than 10 to the power of 8, where 10 to the power 8 is 1 second, right? So this will be solved in around 10 ms of time, and the space complexity can be in the range of order of n square, because these are the total number of sub problems. Okay, I will show you how it is n square. Now we can even solve this more optimally using dynamic programming. Yes, the recursion solution will get accepted because this is an easier problem, but if the constraints were harder, we would have been required to do it by dynamic programming. But why dynamic programming? Because this problem has repeating sub problems as well as optimal substructure. These are the two properties. If they are present in a problem, then you can solve it using dynamic programming. Let's see the repeating sub problem. By taking an example of a plus b into c minus d, which is in the range of 0 to 6 because the length is 7. I have drawn an expression tree number 1 and an expression tree number 2. You can see that when I try to break using certain criteria, then there is a subproblem 4,6 occurring on the expression tree 1, and the same subproblem is occurring in the expression tree 2 as well. So I know that there are repeating subproblems. If you make a larger tree, it will be more prominent. Okay. Now what about optimal substructure? What do we mean by optimal substructure? This means that if this is the entire problem, from let's say A to B is the entire problem, and if I get the answer for two parts, like let's say this answer is X and this answer is Y, can I combine this into the solution from A to B? Can I use the already calculated sub problems to get the entire answer? Like what if I say that I have A plus B plus C plus D, but I say that A plus B is X and C plus D is Y. Can I use this X and Y and find out the sum of A plus B plus C plus D? I mean, yes, in this case. And if this property exists, then optimal substructure property exists. Because if optimal substructure property does not exist, then why are we saving the subproblem results? Okay, the subproblem results should be reusable. Okay, and that is why this property matters a lot. Okay, so in this problem, both this property holds true, and therefore this problem can be solved by dynamic programming. Now let's see how many subproblems do we have. In the constraint section, it was mentioned from 1 to 20. So if we just normalize it from 0, it will go from 0 to 19. Okay, so that is the value of low and high, because index always starts at 0. Now the number of possible ranges will definitely be order of n square, because we are talking about all possible subarrays in an array of size n. Okay, and if you want to understand it even more, then I can fix the endpoint to 19 and the start point will range from 0 to 19, from 0 to 19, 1 to 19 and so on from 19 to 19. Again I can fix the high value, that means the endpoint, to be 18, and I will iterate from 0 to 18, then 1 to 18 and so on till 18 to 18. And it will keep on going until I will have an endpoint, that means the high point, as 0, and I will iterate from 0 to 0. So in this case the number of sub-problems are 1, that is the number of sub-array is 1. Then the next range where you will have endpoint as 1, you will have 0 to 1 and 1 to 1. That means there are 2 number of sub-problems and so on. For the largest one you will have n number of sub-problems. If you add all these numbers, it will be n into n plus 1 by 2, which is order of n square. Okay. So these are the number of sub-problem, and that is why if you want to store all the results, the space complexity will be at least order of n square. Right. Now let's understand the DP solution. Before understanding it, let me tell you what is the meaning of the cell in the table. Okay. So the meaning of the cell is, let's say if I pick 0, 0, what will be written here? It will be storing the result if the question only contained this segment from 0 to 0. That means if the string was only 2, what will be the answer? It will be 2 only. Okay. Now what will be stored at let's say something like 0, 2. The answer if your question was 2 minus 1, that means 0 to 2. So which cell will give me the answer? It will be 0, 4. So this will be my answer cell. Okay. I hope you are understanding this. Now from 0 to 0, if you just have 2, then how many answers do you have? You don't have any operator, right? So answer will be 2. So let's first calculate the smallest sub problem. It will be of size 1. That means only a single operand. Then you have an operand at 2. So 2 to 2 answer will be 1. 4 to 4 answer will be 3. Now let's do size 3 sub problem. That means 2 operand and 1 operator. So 0 to 2. How many possible ways can you bracketize? There is only one way. If you have 2 minus 1, there is only one way to bracketize it, right? So the result will be 1 here. Now if I consider 2 to 4, in how many ways can you bracketize if you have 1 plus 3? Only one way, right? So this will be 4, 2 to 4. Now let's look at the larger problem, like 0 to 4. Okay. So if you have 0 to 4, in how many ways can you bracketize? You see, I have already shown all possible ways using the 2 expression trees. In these 2 ways you can bracketize. So the answer at this point will be appending all the values of each of the expression tree. So the number of expression trees will actually tell you how many answers it will have. So according to expression tree number 1, if we calculate the result, it will be minus 2. So minus 2 will be present here. According to expression tree number 2, if you calculate it, then you will get an answer equals to 4. So 4 will also be present here. Therefore, this memoization table or the DP table will be a 2-dimensional table, yes, but there will be an additional dimension of vector which will actually store how many answers are present. Okay. So in this case, the answer will be minus 2, 4 because we needed to solve from 0 to n minus 1, the entire range. We needed to apply all possible bracketization and get all possible answers. Okay. So remember that the number of expression trees will give you all possible different answers, and that you have to append and return. So in this case, the time complexity will be order of n square is already present for the number of sub problems, and for each sub problem we have to iterate and find out at what all points do we need to divide and form the expression trees, right? That means using doing the binary partition at the operators. I will show you in the code. Time complexity is n cube, space complexity will be order of n square. Now just before moving at the code, let's say I want to multiply and the left hand side results had actually 2 expression tree. One of the expression tree returned A, another expression tree returned B. On the right hand side also, let's say 2 expression trees returned C and D. Then if you multiply, then there will be 4 possible results, AC, AD, BC, BD. So you should remember that. Okay. Whatever operator there may be, you will get a combination of result, because each item on the left side will be combined with every item on the right side, be it multiplication, minus, or whatever operator it is. So let's now look at the code. In this code, this is the main function where the initial call was being made. So the expression was given, and here I have defined a low value which is 0 and a high value which is n minus 1. And then I am making a call to try all possibilities. Okay. So this is the all possibilities function. this is a recursive function, and given an expression, at every operator I will try to divide it at that point or not divide at that point. Okay, so you see that if the range was already calculated and saved, then I will be returning it, because I'm checking it based on size, not by -1, because this is containing an array. Okay, so this is not just 2 dimension, it is actually 3 dimension, right? Now if it is calculated, I will return it. If it is not calculated, I will calculate it. So it will be stored in the answer. Now this one is actually iterating over an expression. So if this is the expression, we will be iterating over it using the I loop. And if I see an operator, then only I will have a choice. So this line, line number 17, actually checks if it is an operator. There were only 3 operator, plus, minus, multiply. So I will check if this belongs to any of the operator. Then what I will do is I will try to divide it into 2 parts. So this is the left part and this is the right part. Okay, and I will calculate all possible results from the left part. On the left part you will get A, on the right part let's say you got X. So the left part, all possible answers will be in the left array. In the right part, all possible answers will be in the right array. As I had shown, just a simple example, let's say this is the left part and this is the right part. Now what I need to do is, when I get left part and right part, I need to combine them both and get the all possible results using the current operation. You see that these 2 loops are used for combining for each item on the left side. That means for A, I will be iterating for C and D and combining A with both C and D using the given operator. Okay, so that is what I am doing here, and I will be pushing all the results based on whatever was the operator, and finally I will be returning the result. Now this line number 29 and 30 is actually about a base case where you just have, let's say, a single item and there were no operators. So in that case you should return the single item, let's say 29, and you should not return 0 or anything like blank array, right? So that is that case. And this extract number is used for basically converting a given string into integer. You can just think like that. Okay, so I hope you were able to understand this entire explanation. If you have any doubt, then please comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.